We have already discussed our type of instruction. Now in this video we will discuss about store word. We know that the format of store word is SW $T0, comma 32, comma S2. Now the opcode for store word is 35. The RS value is 18, RT value is 9, and the 16-bit numbers represent that of which index we want to fetch the value, we want to store the value to. Now we can also divide this using the bit range operation, which is 0 to 15 value is specified for the index number. RT value should be between the bits 16 to 20, and 21 to 25 is reserved for RS. The opcode is from 26 to 31. Now we can look at here, for storing the word we first need another component, which is DM, direct memory. Now let's see the data path for store word. We have to add direct memory, to which we have to provide the address, and we can read the address. We can read the data from that address, and we can write the data to that address as well. Everything is same like our type of instruction. We have only added DM right now. Let's connect this path. Let's add these multiplexer and sign extension. Don't worry, you will understand about the instruction when I draw the data path. First of all, the program counter gets you the address of the instruction that you want to fetch. That address then translated into instruction, and that instruction is being divided into three parts, which is RS, RT, and RD, which is not valid in this case because we have already studied that we need RS and RT. This RS value, we know that we have studied here. This RS value is this one. This RT value is this one. This 16-bit number is here. What we want to do is to add this 16-bit number with this RS to get the address in DM where we want to store this T0. So RS should add with this 16-bit number. We have to pass on RS and this 16-bit number to ALU. So that's what we are doing. RS has been passed on This RS has been passed on to RF to read the data from the register. This gets you the address, and this gets you the data, which is then passed on to ALU. Now we know that the data should be of 32 bits, so we have the data from the index value, which is of 16 bits. We have to sign extend this. This is sign extend. To sign extend this data to 32 bit, pass that data on to ALU. That data is been summed up here and been passed on to DM here. Now we have to get the data from RT. This reads the address and this reads the data, which is then move on to here. We don't want to pass it into ALU. This is the data that we want to write. We have already get the address. Just put that data to that address. This is how we solve out store word. And then also we have to increment the piece program counter with 4 bytes. So we add 4 to program counter. Now this is the data path for store word. Now let's see about the what kind of changes we have to do for store word, for load word. For load word, we know that we have to load data from DM to RF. Everything is same. Just have to bring a multiplexer here to put when we read the data from DM, we have to pass that data on to register. So the path for load word is program counter to instruction memory, which then gets you RS. We have to translate that address, so we have to pass on that address to get towards the address in DM. So the 16 bits move on here, sign extended, and pass on to this multiplexer. One is select on this multiplexer and passed on to ALU. Now we want to write data, so that's why we have added this multiplexer. In load word, we are loading the data from DM to or register, so that's why we need to open this RT for writing the data. That's why we have added this multiplexer to reach to this part. It is now waiting on this position for data to be written on this address. Now we have already seen that RS has been passed on here, the address has been passed on here. We fetched the data from here and passed that data to ALU. Those 16 bits with sign extension has been already passed to this ALU, which then generates an address of DM. We read the data from that address, and on this multiplexer we select 1 and pass that data on to RF. The data has been arrived. We can write this data on this address, and of course we have to increment the program counter as well. So this is the data path for load word.